Press and record. We're recording now. Awesome. First off, thank you guys for coming by and watching this. I've been doing these webinars. I've done like 4 of them now. And like I said to some of you guys before, I'm not perfect at it yet. So if there's something that for instance, I'm talking about and you should be seeing, let me know, because usually it's on my end, not your end. And a subject that's already come up, the little microphones. You guys, I can't hear you. I generally turn everybody's mic off. You can raise your hand and then I can unmute you. But for the most part, there's just too much background noise, and it becomes really confusing and pretty annoying. It's like having a conference call and everybody's talking on top of each other. So, and there's a little bit of a lag time. But anyways, my name is Miles Burghoff. I'm a tournament fisherman. Some of you may or may not know me. I fish FLW tournaments, BASS tournaments. Also fish a lot of regionalized tournaments here on the West Coast now that I live over here. And I also co-host a television show called Sweetwater. It's on NBC Sports, Sportsman's, and Destination America. So that's a little bit of about myself. This webinar is going to be all about electronics and simplifying the electronics. I mean, that's pretty much what we want, right? We want to be able to simplify a very complex tool. And electronics nowadays, as awesome as they are, they can be really overwhelming because, I mean, they come with a booklet that's, I mean, it's about an inch thick for each of them. And so it's kind of hard to sift through all that stuff to kind of find the things that you really need to just get out and utilize them to their maximum potential. So that's what we're going to be talking about. The biggest note that I'm going to make right now before we get started is this isn't going to be a brand specific webinar. Okay, I'm not sponsored by any of the major brands. I am sponsored by Navionics, and we're going to be talking about Navionics mapping at the end. And if you guys have any questions about them specifically, I can get really in depth about their products. But this isn't going to be about, the Lowrance HDS 10, touch or 12 touch, Gen 3 or whatever. It's not going to be about the processes of making sonar logs for a certain graph or certain brand. Okay, these are all questions that I really want to answer for you. So at any time during this webinar, you can ask me questions that aren't really brand specific. But at the end, if there's any questions you have pertinent to your brand, whether it's Humminbird, Lowrance, those are the 2 that I have my main knowledge base on, or Garmin or something like that, I'm going to try to help you out. So, just let me know at the end. Let's see. There we go. All right, so what are we going to cover? Again, this is my little disclaimer. I'm going to keep on. Disclaimer, I'm not sponsored by, nor am I an expert of any one brand. I will be discussing the general rules of thumb, my experience, my personal preferences, and things I've learned through experience. The information I share during this presentation can be applied to most brands. So what we're talking about is all the stuff that you need to know about sonar, side scan, down scan, GPS mapping, all these things that you want to learn what the settings mean, what they do, and how to interpret images that you're seeing. That's exactly what we're going to be going through. So hang in there. So again, what we're going to be talking about, we're going to go into a little bit of detail about what units are best for you and the rigging options. We're not going to get into too much detail about that because it really changes from person to person. I don't want to get into a big thing about those kind of units. And I've got a question from David. Well, why no question forum? I can only see what I type. I can see that your questions, so I can answer them, and then I just speak them out loud. I'm not sure if there is a feature for that, and if You're not seeing the slides? Thank you for telling me about that, because now I'm showing your screen. See, that's what I'm talking about. All right, I'm talking about Sonar, but here I just don't know the webinar. Yeah, Daryl, thank you. You rock. See, Daryl did exactly what I asked you. If you see something that, or you don't see something that I'm talking about, tell me about it. So now you guys can see it, and you can see what I'm talking about. So let's move on. So we're going to talk about what is the best unit for you a little bit. The best rigging options a little bit, but mostly we're going to be talking about 2D sonar, side imaging, and down imaging, or side scan, down scan, whatever brand you have. They call it different things. And we're going to talk about the settings, uses, and image interpretation of all of them, because the common thread between all these different brands is that they have these features, this technology, and it's very similar from brand to brand. It's just the way that they present that information, and the way that you can adjust the settings on that information. And then we're going to talk slightly about GPS. There's not a whole lot that I want to get into on that. And then we're going to talk about mapping software, of course. That's a really good subject. Let me clear some of the questions out. All right, so what unit is best for you? And it really comes down to your needs and your budget. So what are your needs? Are you a weekend angler? Are you tournament angler? Are you just GPS? Do you want just depth? Are you tech savvy? Do you have a good eyesight? I mean, these are important questions. I mean, the eyesight thing, if you have poor vision, you want a bigger screen. That's your main focus right there, is a bigger screen, and something that has real quality image differentiation, where you can actually see the difference between two fish instead of it blobbing together to make one. So you want to, if you have bad eyesight, you want a bigger screen, more definition. If you're just a weekend angler, maybe you just want a 2D sonar unit with a GPS, or maybe just 2D sonar. You just want depth, and you want to be able to see what's on the bottom. These are just questions you need to ask yourself. Suggestions. So here are my suggestions as far as that goes. Get the best unit that you can according to your budget. I mean, that's one of the biggest things that I made a mistake on when I first bought my first side imaging unit. It was a Humminbird. It was an 898. So that was like the smallest you could go with the side imaging. And when I got it, it was awesome. But I was so bummed, because I was like, man, I should have spent the extra $500, got the bigger screen on the 998, or the extra grand, and got the 1198. Because the thing about side imaging and some of these really expensive features is that they're really not all that great if you can't see the little details. What use is it if you can't see that 1 8-pounder that was sitting next to a stump that you couldn't see because you've got this tiny little screen, and maybe you're only split screen, so you can only see a little bit. So you want to get the biggest screen that you possibly can. That was one of the things that I really regretted when I first got that first 898. So try to move on up. And I suggest getting a brand, or getting a plotter or a Depthfinder that works with third-party software like Navionics, for instance. Pretty much, actually, all of the brands except Navionics, except for Garmin. Now there's kind of that thing where they in January of 2015 they made it so Navionics sonar charts for Garmin doesn't work anymore. But other than that, everybody uses Navionics. So you want to make sure, that the individual unit can accept the cards, the high quality cards that you buy. So, and I like to recommend that everybody buy a plotter that has Navionics bundled in, so it's a lot cheaper. So again, we're not going to be talking too much about the rigging options. We're just going to go through it. So essentially, there are um, 3 different rigging options. Well, really 4. You can put the transducer on the bow on the trolling motor. But the first one is the traditional transom mounted transducer, where you mount the transducer on the transom externally, and it does have the best image quality at slow speeds. It should. But once you start getting into those higher speeds, you're going to start getting cavitation, and that cavitation is going to cause a lot of interference. You're going to lose bottom contact. And then when you're on plane, it might not even be in the water, so you don't have any bottom contact at all. So it is the best option for side imaging transducers, if not the only option, because most of them won't go through the hole. I don't know which ones do, but 99% of the down scan or side scan, side imaging transducers don't give you a through hole option. Okay. Another thing about traditional transom mounted transducer is that you run the risk of getting it knocked off by a stump. You know, if you run over a stump, could break it off or you know, send it up. And sometimes you won't even know that your transducer has been kicked up, and you'll be getting the wrong depth reading, and it just look weird, and you're wondering what is going on here. Why does this Depthfinder stink? It's not the Depthfinder, it's just kicked up. The next option is through-hole transducer. So you're essentially taking a puck transducer and you are epoxying it through in your bilge in a fiberglass boat, and you're epoxying it to the bottom. That way, it's shooting through the hull. It's sending those sonar echoes through the hull, and this is really helpful in the fact that when you're running full throttle, you should be able to read the bottom the entire time, as long as you don't have a lot of chop. And so on and so forth. As long as that part of the hole is in the water, you've got bottom contact. The problem is, and the trade-off is, that you lose some of that definition. Some of the echo gets absorbed in the hull, so that you lose a little bit of the definition. But that's a small trade-off when you consider that you can see the depth at high speeds, and you can also get you know, the image isn't all that bad. And it's protected completely because it's not outside, it's inside. So you're not going to get it kicked up by any stumps. It's not going to break off or anything like that. It doesn't have an accurate temperature reading either. So that's another downside, but it's called the running transducer. But the best of both worlds is the dual transducer. The dual transducer is, you know, where you have the through hull in the hull, and then you have it connected through some kind of networking cable to a side imaging transducer or another type of transducer on the outside. Okay, and those work together. And the unit, in a lot of units, the unit will decide which signal is stronger. So when you're running, it turns off the side imaging transducer and just focuses on the 2D sonar transducer that you put through the hull, and vice versa when you slow down, and the signal's better on the transom. So that's the best of both worlds, and that's the way that I run all my boats. You know, all my tournament rigs. That's the way that I rig it up, and I do all this myself. It's actually fairly easy. You just follow the directions, take your time. I do it because number one, I'm learning something. If something happens on the road, I can fix it. And number two, there's not a whole lot of people I trust with my boat. I'm a little bit picky, so, but that's okay. Oh, and as far as the trolling motor transducer, here's a little tip. One thing that I learned is that because you have the transducer up against the motor, whether it's Minn Kota or motor guide, you're going to have some interference from the motor itself. So you're going to see some lines. You're going to see some type of interference on your Depthfinder. You can reduce that greatly if you take a neoprene koozie, like one of the real good neoprene ones, not just the foam. You take that koozie, cut a square the size of the base of your transducer, a little bit bigger, and sandwich that in between the motor and the transducer, and that's going to reduce the amount of transmission that's interrupting your sonar echo. So you're going to see a little bit of improvement there. that's a tip that I've been doing for years. I carry koozies with me, and love it. Let me stop real quick. I got a question. Yeah, and it was more of a comment. Andre, who's a friend of mine, he says uh, that he prefers to see better picture than being able to read depth, specifically at high speed, because everything is way back behind him where he fishes. Now, on that note, what I'd like to say to that is that yes, but at the same time, it's also a safety issue for me. If I'm fishing an area that maybe doesn't have all that great maps, and I'm trying to maybe map the area with the Sonar Charts Live program, or logging to upload the Sonar or to Navionics to make their maps better. If I'm doing something like that and I don't know what the depth is, it is really nice to have that. Sometimes it's too late. By the time you see the depth, you're already on a sandbar. It happened to me out in the Delta a few weeks ago. But yeah, it's definitely a trade-off, and it's definitely a situation where it's up to you what you need. Again, all right. So moving on to the GPS mount. This is something that a lot of companies are getting away from as a whole, is the GPS modules. A lot of them have internal GPSs. So when you buy a unit, the GPS module that picks up the GPS satellite signals is inside the unit itself. But a lot of them have pucks. They're external modules that you have to mount somewhere else. Mount those as close to the transducer that particular unit is reading. Okay, for instance, if I have a console unit, all right, and most people do this nowadays, but it's just a tip. But if you have a console unit, your transducer is going to be towards the stern. It's going to be towards the back, whether it's through hull or it's right on the back of the transom. Okay, if you mount that puck close to your graph, you're going to have like 6 feet of difference depending on how big your boat is. So that 6 feet can turn into 10 feet, to turn into 15 feet of difference between when you drop a waypoint on a fish or school of fish or a specific piece of structure, and what the waypoint actually read, or where it dropped. So I try to keep the transducer and the module as close as possible, so you don't have that indiscrepancy, and you've got as accurate of a waypoint as possible. All right, so here we go. This is the real good stuff. 2D sonar. This is really where we need to start. This is really what's going to kind of wrap everything together for everybody. It's really where everybody. Let's see if this. Oh yeah, just pouring some Mountain Dew here. And no, I'm not sponsored by Mountain Dew. I'm just addicted. All right. Okay, so yeah, 2D sonar is where it all began, and that's where we're going to start. So essentially, what 2D sonar does is it takes the transducer sends an echo out, a series of cone-shaped sonar echoes or signals. The transducer then again receives these signals once they bounce off all the different things down there in the water column within that cone, and then it transforms them into a flat image on your screen, based on the strength of those signals that are received. It's so important to remember that you're not looking at a picture of the bottom, okay? You're looking at a flat representation of a cone that creates this. It's not only just the cone, but it's the circle of the bottom that it's receiving back. So if you see a fish, or you see something on the graph, it could be to the right, it could be to the left, could be in front of you, could be behind you, but you're seeing it on a flat screen, so it can be very misleading. One thing to remember that's also really important is, let me try to move this stuff around, use the pen. Hold on one second. All right, so this little picture on the bottom here, this is a screenshot of 2D sonar. Okay, all this information right here is outdated. This is all stuff that really doesn't matter all that much. You've already seen it. This is the past. Okay, past. This right here is the present. This is what is underneath your boat at this moment. This is what the sonar signal is reading, and that's right now. That's present. So that's what you need to focus on. Forget all this stuff in the past, unless you want to go back to see something. But that's right now. Now you see, I've got a question here. Yeah, I wish. I know. I wish I had. He said it would be nice if you had examples of the equipment you're talking about. I'm going to have a lot of pictures here, a lot of pictures to show you and things throughout this. And I've actually got a sonar, the sonar phone, the Vexlar sonar phone on my iPad that I can use the demo mode and show you. So we're going to do that. But obviously, I can't hold up a Depthfinder because I don't have it in front of me. My boat is somewhere else. And not only that, but this seems to be a little bit better, so I can show you on these pictures. Okay. Okay, so let's talk a little bit about the things that really confuse us and perplex us, the things that we really want to know and learn about. And those things are the settings. Okay, all these different things that you aren't sure exactly how to adjust to fit the conditions, and that's what we're going to talk about right now. Okay, first thing you want to remember, you need to make adjustments according to the conditions. Okay, make adjustments based on water clarity. See, water clarity is really important, and a lot of people don't think about it. If you're in clear water, there's not a lot of debris in that water. There shouldn't be. There's not going to be a big algae bloom because it's clear. You know, there's not a whole lot suspended in the water column. But if it's dirty water, there's a lot of debris. There's a lot of different things down there, whether it's plankton, temperature changes, there's an algae bloom, whatever it is, that's going to affect the performance of your unit. And that's why you need to make these adjustments on the fly where you're fishing, you know, the types of lakes that you're fishing. The factory settings are great. Don't get me wrong. Those do work, but it's really important to change it based on the conditions, okay? Okay, so sensitivity. This is probably this is definitely the first thing that we need to talk over. You need to consider it the hearing aid of the Depthfinder, of the transducer. Okay, so if you had a hearing aid in and you turned it all the way up, you would be able to hear everything. Your ear would just be blown out. You've just got all this different things coming in, and you can hear, you know, the guy cooking bacon and next door, and kids screaming, all kinds of stuff down the road. These are the things that you don't want to hear. You want to maybe listen to the TV or something. That's the information that you're trying to get. You don't want to hear everything. So that's the same thing with a Depthfinder. When you turn the sensitivity all the way up, the transducer is hearing much more. It's hearing much more down there. It's picking up all those things that really don't mean anything to you, aren't usable data. It's stuff like the algae that we talked about, the floating debris, all this different stuff that you really don't care about, but because you have it all the way up, it's making it too cluttered. The screen's too cluttered. There's not enough definition there. It's just blown out. But if you turn that down, if you turn your hearing aid down a little bit too low, or way down, then you can't hear the things that you're really focused on. You can't hear everything on the TV. You can just maybe hear just a little bit of what they're saying, but it's just not right. And the same thing with the transducer. If you turn it all the way down, you're not going to be able to see the bait fish that you want to see. You're not going to be able to see the little details, like maybe there's a clump of grass. Those are things that you want to see, but you're not seeing because you turned it too far down. You want to. There's a happy medium there, and we're going to talk a little bit about that. And so actually, here's a good example, a good visual example. So we'll do this real quick. This is something new that I haven't done before. All right, once this comes up. All right, so this is the Vexilar Sonar phone. So this is in demo mode, so you can see this. So the gain down here is actually sensitivity. That's they call it, in saltwater depth finders and plotters, they're going to call it, gain a lot of times. If you increase this isn't going to increase to the point where I'm saying that it's blown out. In fact, this one, it 100% isn't all that bad. But if you brought it down, it's a good representation. If you brought it down, all of a sudden those fish start to disappear, and you don't see what you want to see. That's the information that's usable. But then if you bring it back up, all of a sudden those fish start to reappear. Now, if it was too high on most units, you would actually get, instead of the white in the water column, you just see blue or red. It would just be chock full, especially if it's muddy water or something, because it's picking up all that stuff that you don't care about in the water column. But that's why there's a happy medium. You got to figure it out on the water, and you can put it on you can keep your unit on man or automatic, but I really suggest doing it on a case-by-case basis. All right, and we're actually going to be talking about that in the next slide too, so I don't know why I got in the detail. All right, next we have ping speed. So ping speed controls the amount of sonar signals that are being deployed per second, okay? Depth range controls the depth range that is shown on the screen. Say you set it to 20 feet. That's the only depth that it's showing. It's showing between 0 and 20 feet. Fish ID, this one, we're going to be talking a little bit about this. It's essentially where the unit guesses what signal returns are fish and replaces the real image with a fish image. It's very misleading and it's highly inaccurate. It's really not a feature you want to be using, my opinion. Now, sonar frequency, which is the first thing we're going to talk about as far as how to set things, is the frequency of the signal being produced by the transducer. It's usually 200 kilohertz, 83 kilohertz, 50 kilohertz, so on and so forth. Some units, some different brands will use different sized or frequency sonars. So, but just get an idea of those. Anything close to these numbers that we're going to be talking about, you can apply that to your unit too. Okay. So 2D sonar settings. These are the things, and we're going to be talking about frequencies here. Okay, so this is something that's really important that I didn't learn right off the bat, and I was really missing the boat with this because I didn't think it was that big of a deal. I focus more on sensitivity, and I think people focus more on sensitivity and some of the other settings, and they miss out on the real important stuff like frequency. So first off, we've got the lower frequency, 50 kilohertz. All right, that's for deeper water. Lower frequency is going to be able to penetrate deeper water much better than the higher frequencies, which will kind of be filtered out by then. Okay, so the deeper water, 300 foot plus, if you're a saltwater guy, you're fishing that super deep water, that's the frequency you want to use. Has a real broad scope. You're scoping out a lot of area down there, and it works in real deep water. 83 kilohertz or something very close to that is great for freshwater. It's great for analyzing structure or cover, and it covers a wider area. You can see down here in the picture, which I will highlight, down here in the picture on the bottom right, you've got this image of the sonar cone. The 83 kilohertz is right here. It has a much wider circle. It covers a much wider area than the 200 kilohertz. Okay, so that's great for when you're on your big engine, you're motoring around, and you're trying to find the general locations. It's great for finding fish. You find a lot of fish with it, but it doesn't define them as well. It doesn't. Like 3 fish tightly packed together will look like 1 fish sometimes. And so, but 83 kilohertz is great for searching out structure, searching out those big schools. But then once you find those big schools, or you want a good frequency for your bow unit, 200 kilohertz is awesome because it has the best target separation. You can see those 3 fish instead of just seeing 1 blob. And it has a much narrower cone. Okay, so you're covering less of the bottom, you're being more precise, you're seeing what's directly underneath the boat instead of seeing something that may be over here, or it may be right underneath your boat. But in 200 kilohertz, it's underneath the boat. So it's excellent for catching vertical fish, fishing a drop shot or something vertical, a spoon. 200 kilohertz is great because it's got a very precise cone and frequency to get those fish right underneath the boat. So on that note, as far as cone angles go, you can see the 86 or the 83 kilohertz cone angle is much greater. So if you draw a straight line up, okay, so that's everything within that area on the bottom is what is being sent to your screen. So that flat image that you see that you assume is directly right underneath the transducer may be, depending on the depth, because it changes based on the depth. As you get deeper, that cone gets wider, that circle gets wider, and the diameter can be pretty big. And there's formulas for that too. And you can find them pretty easily online for the different kilohertz. You can find out how wide that cone is for the depth that you're fishing for certain depths. So one thing to keep in mind is that with the 83 kilohertz, if you're seeing an image that's kind of faint, more than likely it's on one side or the other, or in front or behind. It's on the perimeter of that cone, that circle. So it's really hard to draw with my computer. Sorry. Okay, 2D sonar settings. So we've already talked about sensitivity quite a bit, so I'm going to kind of skip over that. Again, it's that happy medium. You want to make sure that you bring it up to 100% and then reduce it down to where you're getting rid of all that clutter, that unnecessary info. Here, I'm going to skip over real quick. This is a picture, a screenshot right here on your right-hand side. And this is a great example of an overblown, oversensitive setting right here. You see, the water column is dominated by all these different colors. You got the blues, you got the reds. It's picking up all that unnecessary data, all that unnecessary stuff that you don't care about in here. And there's probably bait fish in here. There's probably bait fish in the water column somewhere that you just can't see because of all this stuff. But you look over here, the white, everything in there, that's the water column that you want to see, because then you can see the bait fish and things. So that's just kind of an example of good sensitivity and bad sensitivity. Ping speed, 100%. If you have the option, put it at 100%. The reason for that is you want the most recent data, and that means that you aren't, if you bring it down to say 50%, so it's sending a ping down 50% slower, you're getting less current data by doing that, because while you're moving forward, you're getting less signals coming back, and so it's just not as current. So you want it at 100%. There's really no reason not to, in my opinion. So ping speed 100%. Chart speed. Chart speed is just how fast the chart is moving. So let's go back to the sonar phone app. Okay. Well, shoot, now you can see my, let me take that away real quick. All right, so we'll be mirroring in a second here. All right, there we go. So if we change I think we can change the speed in demo mode. Maybe not. Chart speed. I can't do it, unfortunately. Sorry, bad example because I can't do that with. But anyways, so chart speed just controls how fast the chart scrolls across your screen. And when I'm idling or going on the big engine, I'm moving from spot to spot, maybe doing a slow on plane, back and forth, a Z pattern to kind of find some areas. I want that moving fairly fast because that means that that's the most recent data. It's keeping up with all that data that it's receiving, so it's not all stretched out. If you're on the bow, maybe it doesn't need to be all that fast. You can keep it a little bit slower, but don't keep it really slow. Put it at like 50% or 60, 70% or something like that. But kind of get a feel for that and how that affects the image. Because when you're moving on plane and you go over like a trench or something, if it's going too slow, then it'll kind of stretch that image out. If it's going too fast, it'll make it too narrow and you might miss it. So it's kind of, again, a happy medium. Depth range, this one you can use auto mode. I really don't have a problem with that. There is a couple of things that I like to use the depth range in manual mode for, and we're going to talk about that. It's really good for finding a double echo, which pertains to finding hard bottom, which we're going to be talking about that kind of image interpretation. And then depth range is also really important because if I'm fishing 10 feet of water or 20 feet of water and I want to get the maximum detail out of the screen, then just set the screen at that depth, the maximum depth that you're fishing, because then it's not going to, on a whim, want to automatically switch over to 20 feet if you're only fishing 10 feet, because then you're looking at 10 feet of unusable bottom images, and then you've got 10 foot of the water column that you're interested in. So I like to set it at the depth that I'm fishing. That way I've got all that usable information and I'm kind of utilizing all of it. I've got a question here. What if you are in deep water and depth range is set for shallower? So if you set it for shallower, obviously you want to set it for the depth that you're fishing. Automatic mode can mess you up in the fact that sometimes there's some kind of interference or something happens where it is showing 5 feet of the water column when you're in 25 feet of the water. You're in 25 feet deep. And that's just because it's on auto mode, so it's like it's got some weird information, and now it thinks that it's in 5 feet of water, but it's really in 25 feet. That's another reason why manual mode's so important. So I set it for a much deeper, I set it for the depth that I'm actually fishing, case by case basis. The Depthfinder is going to do the best that it possibly can, just like it's going to do that with the fish ID that we've talked about. But it's really not going to know 100% of the time. You're the best judge as far as that goes. You know what's going on. You know you're in 25 feet because it was just reading 25 feet. You could see the bottom as clear as day, and now it's freaking out, and you only see like part of the water column. So that's another reason why you want to set it manually. And like I said, not an expert on all different brands, but all brands have an option for depth range. So you just got to kind of go figure out what that process is to get that option. Fish ID off. The thing is the biggest. It's really just a gimmick. It really is. I mean, it can sometimes work just the way it's supposed to, but it really isn't necessary at all. And it gives you fish pictures like if you run over a tree, a submerged tree, or a brush pile, it's going to show the branches as fish. There might not be a single fish, not even a little bluegill in that brush pile, but it's going to show every single one of those branches as fish because it doesn't know any better. It doesn't know what what's down there. It's only getting that echo return back, and that way then it's presenting on the screen, and the screen's kind of guessing what it is. So fish ID off. All right, so let's actually get into some visual stuff. I agree, I'm a visual learner too. So let's talk about image interpretation as far as fish goes. Okay, now the first thing that we're going to learn is what is up with these arches. Like what's the deal? And one thing when I first started using Depthfinder sonar units is I got frustrated because everybody's just like, yeah, I saw such a big arch and arches all over the place, and you're like, what are you talking about, man? All I saw was blobs down there. This is that just blobs and worms, big old lines. So let's kind of discuss the arch and why it is an arch. And each different Depthfinder is going to analyze it a little bit differently. I had a hummingbird that the fish did look like blobs. No matter what I did, it was more of a blob than anything. But I've had other units that did the same thing. So it's, for the most part, it's arches that you're going to see. But the thing about arches, so let's look at this. On this top left-hand picture here, you see all these really defined arches. They're really easy to see. These are all fish. Every single one of these is fish. On top of this hump, whatever, a point, whatever that is. Essentially what happens is the way that these arches are created is you have to be moving. Either you, your boat, or the fish have to be moving through that cone at a decent speed to become an arch. Okay, so as you move over a fish, okay, let's pick. It's kind of hard to pick these now that I've messed them all up, but let's pick like this one right here. So pretend this is the cone coming towards the fish. It hits the edge of the fish. It's a real weak signal. As the fish gets towards the center of the cone, it gets stronger. You start to see that real vibrant red. It's a real strong return. And then all of a sudden, the boat gets out of range. The fish is going outside of the cone, and he's gone. That's what creates the arch. Okay, so you got to be moving. So if you're standing still and you're not seeing arches, don't be frustrated, because you're not going to see fish as arches. The only time you'll see fish as arches when you're standing still on the trolling motor or something like that is that if it swims through your cone real quick. It swims through that echo real quick, then it'll be an arch because it's moving through it real fast. It starts out as a weak image, gets much stronger, and then it starts getting weaker again as it exits the cone. This image down here below that, this kind of resembles fish these are fish that are underneath a boat that is going much slower. It's still moving a little bit because it still has an arch shape to it, but it's stretched out more, which means that those fish were inside that cone much longer than they were up here. Okay, so this could be you're on the trolling motor and you're trying to find these vertical fish. They're going to show up as these squiggly lines, and hopefully they're squiggly. If they're just a solid fish, a solid line above the bottom, parallel with the bottom, it's not really feeding. But if you see those squiggly lines like these right here, these are pretty good. You see those? They are feeding, and you better get a drop shot down to them or a spoon or some kind of vertical presentation because they're chomping. Okay. Now this picture over here, again, it's really blown out because the sensitivity is really high. These are fish right here. There may be some other stuff in there because you can't really tell because the sensitivity's blown the image out. But these are all fish. Generally, fish like bass that we're really focusing on aren't going to be stacked on top of each other like straight up and down. Vertically, they're not going to do that. What they're going to do is they're going to end up they're going to end up sorry, I was reading a comment real quick. They're going to be kind of bunched up close to the bottom and not really stacked up as much as just kind of spread out. They don't really school like a bait fish would. There's some species that'll kind of stack vertically, but generally, if you see fish stacked vertically, it's something else, which we're going to talk about right now. Okay, so let's talk about cover, figuring out what cover is. And I've added some screenshots of downscan in here too, because you can see the definition. You can actually see the little details of what we're looking at on the 2D. Okay, right here, let's start with vegetation. Vegetation, this is the bottom right here. Okay, bottom is on that, and this is all vegetation right here. Okay, it just shows up as a lot of interference. It almost looks like the bottom, like it's a real soft bottom, but that's how it shows. And different vegetation is going to show up a lot differently. You know, for instance, eelgrass. Eelgrass shows up as really strong signals, really thick. Almost looks like a rock pile sometimes. You know, be in little splotches. It'll look like big rock piles here and there. A lot of the times that's how it grows. You know, hydrilla or milfoil generally will look like this. This is exactly what this type of grass is probably a milfoil right here. But yeah, you can see how it kind of just is distorted. It's not really a solid image like this down here. This is a brush pile directly below it. It looks like kind of fish stacked on top of each other, and that's not what it is. It's there's probably some fish stacked in there. You can see on the down scan there's some fish. God, I make awful little circles on this thing. Yeah, you can see like little things that it looks like they're fish there. But this right here, as far as brush piles go, yeah, it's hard to tell that that's a brush pile. You'd think it might be you know, a little bit of grass, but generally grass will grow up a little bit more thick. So down here, you won't see like this bright spot here and then a lighter spot over here. It'll just be all bright or all one color, kind of distorted. It's kind of hard to explain that one, but visually you can see it. All right, and so let's go over to the right-hand side. This is standing timber, okay, and this is where people kind of get it wrong. And I when I'm out of my boat and we're going through standing timber, I've had a lot of people say, "Whoa, man, look at that! Look at all the fish there." Like this right here, that's very misleading. Okay, you got the white, which is all the water column, and then you have these arches here that look like fish because there's nothing in between them. What's happening there is it's standing timber, but what's happening is that only some of the branches are entering into that cone, the sonar echo. Only some of them. So you're only seeing some of the tips of those branches entering in there. And again, I warn you, fish, especially bass, do not school vertically like this in most cases, okay? So if you see that, it's normally a tree, all right? Same thing with this, that's a tree, and this is a tree as well. This one's way more obvious, and the reason for that is that you are going over it, and it's directly below the transducer, which means that it's a much stronger signal. It's not on the outskirts, it's right below the boat. That's why it's colored that way. And so you can tell if that's right beneath the boat. These you can tell, these are on the sides. God, awful at drawing on this thing. So yeah, you can see if it's on the side or not. All right, so bottom hardness. This is a subject that is really important for us bass fishermen because we're always looking for that hard bottom. This is really important, and and your depth finder is such a good tool, if not the only tool in deep water to figure out if there's hard bottom there. So the first thing I gotta point out is that the sonar beam is going to go down. It's going to go from the transducer. It's going to go down to the bottom, and it's going to bounce back up. When it hits the bottom or hits whatever, it could be a fish up in the water column, it could be a tree or whatever. Some of that transmission, some of that echo is going to be absorbed into that, and especially on the bottom, it's going to be absorbed. The softer the bottom, the more that is going to be observed. It's like screaming into a pillow, okay, or screaming into, you know, a granite canyon, you know, that you're going to get an echo back from a granite canyon, and in your pillow, you're just venting your frustrations. So it's with the sonar, when it hits the bottom, hits a soft bottom, less of that signal is going to be returned to the transducer, so you're going to get less of a return on your screen. See how that is really thin behind this awful circle? That is actually soft bottom. And then of course on either side, you've got this really strong return because that transducer, that ping, that echo hit hard. Not a lot of it got absorbed, and it went right back to the transducer, and it got a really solid image. Okay, and you're going to see that really solid color, that really bright coloration. This changes from different brands to the brands, and you can change the color settings and so on and so forth. So, you know, it really depends on what graph you have. But generally, like Humminbird and Lowrance, mine are all yellow. When I see yellow, whether it's a fish or bottom or whatever, I know that's a really strong return. So if it's a fish and you've got real bright yellow coloration, like we'll go back here. This happens to be red in here, but you go over here, these fish that you see the yellow in the center of them, those are bigger fish. Those are the kind of fish that you're looking for. The ones that maybe are just red aren't going to be as big. Like these right here, these are solid fish, especially this one down here that has a little bit of yellow in it. But when you have that real solid yellow, in this case it's red, those are quality fish. Just a note. All right, and so as far as like the depth range that we talked about, a reason that you might want to do it in manual again is because you can find the double echo. All right, this is what we call a double echo down here. A double echo is essentially an image. It's like a phantom bottom. Okay, so you've got the sonar image or the sonar beam that goes down, hits the bottom, and it's a really hard bottom, so it comes back up and then comes back down real quick and then comes back up, and then it creates not only the true bottom, which is this right here, that's actually how deep it is, but it also sends the unit an image of another bottom because the image is so hard, it got such a strong return that it's creating another image exactly 2 times what the depth is. So we're in 30 feet. So you're going to see the double echo in 60 feet. So when you see a double echo like that, you've got some really, really hard bottom. If you have the unit too sensitive, you might see a double echo all the time. So you want to reduce that so you're only seeing the true double echoes. But you can also see here that there's a lot of yellow, like we talked about. It's real bright. It's a real solid image. So side scan, side imaging. This is the new age technology. Everybody's excited about. I'm excited about it. I mean, it's been out for a decade now. So, but I love it. It's unbelievable, and 2D is definitely not outdated, but it's something that you have to use side scan nowadays in tournaments and things like that, because it is a really useful tool in conjunction with everything else. What it is instead of having a cone-shaped signal being sent straight down from your transducer, you have a transducer that sends off two paper-thin beams at 90 or like 86 degrees on either side. Okay, so paper-thin, it's like going perpendicular to your boat on either side, and then it combs the water column with those two beams, and it can go out to like 360 feet on either side depending on the unit that you're using. You're able to see directly below you, you're able to see side to side, and they even have products that you can see in front of you. We're not going to talk about 360 imaging because honestly I don't have that much experience with it yet. And then you've got like Panoptics and things like that. But anyways, the side imaging, side scan uses high frequency signals like 445 kilohertz, 800 kilohertz, so on and so forth. It has superior target separation. It's so clear. It's like a picture of the bottom. It really is, if you've got it set right. And one thing you've got to remember is that you've got to be moving between 4 and 6 miles an hour to really get a true picture of the bottom in most cases. There's some advanced settings and some things that you can do to get a really good image when you're like on plane or something, if you've got the capabilities to do that, which most of the time you're only going to be idling with it. But we're just going to be talking about the 4 to 6 mile an hour, because what you're doing is, imagine those two paper thin beams are going off at either side of your boat, and you're able to see down and to the side. If you're standing still, all that's showing is the same spot on the ground, but it's stretched across your screen, so it's just going to be this big stretched image. What I learned when I first started using side scan, it was the coolest thing. I went over, it was the first day I had it, went into this canal on Lake Tahoe in Florida, and I ran over a tire. Like, I saw it as clear as day. I was going 5 miles an hour. That was the idle zone, and I saw this tire on the ground. I'm like, holy cow, that's awesome. And so I went back, but I slowed down to like 2-3 miles an hour, and that tire was like stretched out oval. Okay, so I was like, oh, well, that's weird. So then I went back around and just for fun went over it really fast, and it ended up condensing it into an oval that was really narrow. So what I learned that day was that there was that happy medium where you're actually painting the actual image of the bottom if you're going the right speed. Okay, so it may be kind of hard to grasp, but you've got to be moving forward for that to really create the image. That's why I don't use it on the bow much. I use down scan, but I don't use side imaging on the bow much. Down scan, down imaging uses same frequencies as side or down image or side or side scan, whatever, but only shows you what's directly beneath the boat. It's kind of a hybrid between 2D sonar and side imaging. It's excellent for target separation and easy image interpretation, and it's the perfect complement to your 2D sonar because you can actually see, like we showed you before, that brush pile. You can see the limbs in it. You can see the fish that are suspended around it, and it's not just this big blob. You can see the tree. You can see the grass. You can see what kind of grass. So it defines those things much better. All right, so here are some settings for side and down scan. Surface clarity. You want to turn that up to reduce the surface noise. What you're going to see, and you might have this option for your 2D sonar too. So a lot of times you're going to have a lot of interference from your motor, from bubbles, whatever. You want to turn up the surface clarity so you reduce that unneeded noise. And the same thing with noise rejection. Turn that on, and that will make sure that you're not getting as much, if not any, of the electrical interference. You could have a bilge pump running, and you're getting some kind of signal from that. That'll reduce that. So it's a good idea to turn that on. Sensitivity, same thing. Make adjustments based on the fishing conditions. Try it on the water. if I'm fishing around grass, I'm going to go ahead and reduce that a little bit so I can kind of see through the grass a little bit. You can actually do that where you see, you can kind of reduce the amount of grass that you're picking up, and you can see through the grass, and sometimes I can see fish. So I can actually see the fish in the grass by reducing the amount of sensitivity, but you don't want to reduce it too much. And sometimes you want to increase it, because you're maybe around a lot of muddy bottom, and you want to increase it so you get more definition. You want a stronger, beam. As far as range goes, this is something I see a lot of people make mistake with, is that they want to see as much as possible. They want to see 360 feet, the maximum amount. If you do that, you're missing so much little details. You might be able to see the giant, drop that's on the right-hand side or whatever, but you're not going to be able to see that little school of fish that's hanging around that invisible stump that you should be able to see. So I always keep it between like 35 and 60 feet, depending on where I'm fishing. If I'm fishing deeper, generally I will move it up a little bit, because you lose a lot of your bottom from the actual water column, which you'll understand when you go out there. Contrast. Again, adjust to current conditions. This one and sensitivity kind of go hand in hand. You want to for softer bottoms, turn up the contrast to find the subtler, harder bottoms. So it's really showing you, it's reducing the, if your contrast is all the way down, it's going to look the same, okay? But if you turn it up, the harder bottom is going to start to pop, and the softer bottom is going to be a little bit darker than that. So, and with side imaging, the brighter the image, the harder the bottom, the stronger the return. And we're gonna show you a bunch of pictures about that too. Frequencies, 45 and 800. That's what I have on my Lowrance. Those are frequencies that are used for some other ones. They're best for searching large areas in deeper water. 45 or 455 is. That's the same with your 83 kilohertz a 2D sonar. It's the lower frequency is best for searching large areas and deeper water. Now 800 kilohertz is best for definition in shallower water. It's better for defining little pieces of structure, fish, things of that sort. So it's good for once you found the fish. When you're looking for them, use 455, and then when you found them, switch over to that higher frequency so you can really fine-tune that location. All right, so here's an image of side imaging, what we're talking about. This right here is, it's showing you a picture of the bottom. This guy, right now, we're going underneath a bridge, okay? Up here on the top, this is you. This is where you're at right now. This is all the current information. This side, the top is all current. This is all past. Okay. Now let's go back. So now that we understand that the top is what's happening right now, and this is all past, these are bridge pilings. So you've got bridge pilings. The sonar beam is going down. It's hitting the pilings, and then it's creating an echo because it looks like a shadow, but it's actually an echo shadow where the beam doesn't go. So it doesn't have any information about this, so it turns out dark. But what we're going to do right here is I'll show you. So essentially, like I said, this is the front of the boat, or this is the boat right here. This is the top is all the current information. The center is the surface of the water, okay? And remember, you're shooting two beams from either side. So this beam on your starboard is going straight down to the bottom. The black part is the water column, and then it's going over, fanning the bottom of the lake, okay? Same thing over here, going down and fanning the bottom of the lake. So, and usually you're going to have range lines, so it'll say like 10 feet, 20 feet, 30 feet, 40 feet, 50. So you can kind of gauge how far away on either side those images are just by looking at it. But some notes here. This is a pretty fuzzy image, but we'll have some more. But you can see we've got some really harder structures. This is hard. It's because it's white. It's got a really bright return, which means that it's a very strong image. It bounced off the sonar beam bounced off of it, came back, and it's showing up as a strong image. So anything that's darker is either falling down, is either getting deeper, and where it's not getting as strong of a signal coming back, or it is a softer bottom. Okay, and this is all water or bottom that's actually rising. Okay, or is harder bottom. Man, it's hard to kind of explain that. Okay, so here's some pictures of downscan on your top left-hand side. You got sonar below that, regular 2D sonar, and then of course you got your side imaging. On your sonar, it's kind of hard to figure out what you're looking at. You're looking at this kind of blob of red and yellow and green, but then you look at your side scan and your down scan, and you can see that it's a tree. It's a lay down. You got all those branches and everything. And so you can see those little definitions. You could actually see the little fish that show up in the tree if there is any. Okay, and you can see the harder bottom. That tree is on top of harder bottom here, and then it's surrounded by a softer bottom right here, which shows up as the darker image. Again, on this side, because you pretty much ran right over the center of this tree. And so you split it in two on both sides. So that's and you can see how the tree shows up as a stronger image because it's white. It's a harder surface. Again, here's another picture. We've got some fish right here off this drop. You can see that most of this is harder bottom, or the sensitivity is way up just by looking at it. You can see the echo right here. You can see the sonar shadow that's made from the tree. You can, in that way, you can see how tall it is. And yeah, so let's move on. So here's what we all want to know is, what do fish look like on these things? Okay, they don't show up as arches like they do on the 2D sonar. These little, and you'll hear guys, they call them Rice Krispies. I guess that's an okay way to explain them. But these right here are fish, man. This is a killer looking spot right here. You can see the fish, they show up as a strong return, so they're much brighter. They're bright white. Like I said, guys call them Rice Krispies. They just show up like grains of rice all over the place. And the reason that you can tell that these are fish as opposed to like a stump that also turn up pretty white is that they have the shadow. They cast a shadow, which means that they're above the bottom. Okay, when something's above the bottom, they cast a shadow but have a space of negative space between them. So you've got the fish up here, you've got negative space, and then the shadow. So you can tell. And with the shadow, you can tell how high off the bottom they are. This fish is pretty close to the bottom because the shadow is pretty close to his body. If he was way up here and cast a shadow down here, that would mean that he's way higher in the water column. But yeah, you can kind of see how they look. This looks like what you normally see with bass is just the way they're positioned. They're not stacked on top of each other. They're just kind of in a loosely oriented group. All right, moving on. Does anybody have any questions about side down imaging or 2D sonar before we move on? I know some of the it gets really intense, so I want to make sure I answer any questions. Okay, in that case, we'll move on. So GPS, nothing fancy here, just the best thing since sliced bread. Love GPS, man, and that's one of the the best things that a bass fisherman has on his boat. I love it. Okay, now I've got a question from somebody about what's the best color for side imaging. Now, again, I find myself changing the color palette for side imaging all the time, and it is based on how dark it is outside, if it's overcast, if it's sunny. Sometimes I even invert it. Usually I'll keep it like that blue palette. I like to keep it that blue palette, or there's like a light green, like a chartreuse palette. I like those because they're real bright, easy to see, and sometimes I can miss some of the little details if I don't have those bright palettes. Another one I really like is kind of an amber. I like the amber coloration. That one shows up really well too. But generally, I'm usually sticking with blue most of the time. It's kind of a really good all around color. But experiment based on the day. Thanks for the question. Okay, GPS. So there's not a whole lot that I want to say about GPS. It's pretty simple, kind of plug and play. There's not a whole lot of tweaking here. One thing I'm going to note is orientation. Okay, the orientation means how the image of your boat, your position relates to the surrounding terrain. Okay, you can set it so the screen never moves. The terrain never moves and only your boat moves, and that's called north up. So north is always the top of your screen, south is the bottom, east is the right, and obviously west is the left. So it stays in that position. But then you can also do what direction you're facing. So your boat doesn't really move, but the surrounding terrain moves. I don't really like that. I like north up because I know because nothing moves around me. I'm the only thing moving on the lake. So I want to make sure that I kind of have I get kind of turned around if I have the orientation the other way. The north up is good because I know I don't have that map moving constantly if I'm trying to make little adjustments and move, just a little bit. I don't know. It comes down to personal preference, but try north up orientation. I think it'll really help you because it's kind of natural. Okay. So that's all I have to say about that. So mapping. All right. So let's get into a little bit about mapping because it is really important. I get a lot of questions about it. It really pays to get a good mapping card, and it depends on what you need it for. If you are a guy that just has your basic sonar GPS unit, let me get a computer plugged in real quick. If you've got your basic sonar GPS unit and you just want your basic maps, then there's a different card for that. If you're a tournament guy and you want the best of the best, there's a card for that too. So here are the options with Navionics, and Navionics again is for all different brands. Okay, I'm not going to talk about Lake Matt. There's other cards out there, and it's up to you to find which one has the detail for the area that you're in. But I'm going to say, not just because I'm with them, but because it's the truth, that Navionics has the widest reach, the widest data, the most data for mapping. So, and they update their charts. They add like 20,000 new things every week, and that's an old number. So I don't know where it's at now. So it really pays to have a card with them because they offer so much more. But as far as the different products out there, so let's start at the top. If you like fishing nationally, you fish all over the country, and you don't want to have to buy different cards for different regions. There's something called Nav Plus. All right, Navionics Plus, and there's one that's brand new that's called Navionics Plus Preloaded. Has all of the U.S. and Canada already on there. Okay, it has nautical charts already on there for all of their maps for U.S. and Canada. And then from there, you have the option to download Sonar charts, which is their real high definition charts, onto that map. Okay, and you actually have to turn Sonar charts on, which is really important. And then if you want more of a plug and play, chart mapping card, and you only fish one region, say you only fish Texas, then you would want either Premium, the Hot Maps Premium, or Hot Maps Platinum. Okay, Premium just has the nautical charts, which will show you a difference between Sonar charts and nautical charts. It's regional. Platinum, same thing. It's regional. It has nautical charts, but it does have Sonar charts, 3D, and satellite overlay. So that's the real premium product if you're only fishing one region. Or you also want 3D and satellite overlay and those features. Platinum Plus is regional saltwater. It's got nautical charts, Sonar charts, 3D, and satellite. Pretty much the same thing as Platinum, but for saltwater. Gold is another saltwater card. Has all U.S. and Canada. It's got nautical charts in it. All of these give you 12 months free Precious data. It's all free updates. You can update it every single year or day. And I highly suggest it because, like I said, they update their maps constantly. And Sonar charts is actually, it's not just really high definition charts, but it's actually a program where users just like you and me can go out there, log Sonar record Sonar logs, and then upload them onto the Navionics website, and then they generate maps and improve their maps based on that. And it's extremely accurate, and it's really good for shallow water especially. So let's move on. I'll show you the difference between Sonar charts and nautical charts. So up here, this is from their Navionics web app. The top image is nautical charts. Not bad. Good detail. It's all that you'd really need if you're just doing basic fishing. You just want a navigational aid and good contours. But then you go down here and you see all this 1 foot contour detail. It's a lot more detailed, and every lake seems to have a little bit more detail that I go to. So it's you can definitely see the big difference here, and it's especially useful in shallow water because it has that 1 foot contours, and it's the most up-to-date mapping software out there. And a note on that, the thing that I see most of all across the country is that guys, even elite guys, the Bassmaster Elite Series guys, I've sat next to them. I had a couple last tournament that I fished that I saw their charts. And I'm like, hey, do you have a Platinum card or Navionics Plus? They're like, yeah. Just like, why don't you turn on Sonar charts? They're like, what? You have to turn something on? You actually have to go into your unit and turn on something like in a Lowrance, it's called Fish and Chip, or in a Humminbird, it's called Fish and Chip. You got to turn that on. That activates Sonar charts. So it's an actual extra step, but it's something that allows that overlay to be apparent. So when you buy these cards, don't just assume that you plug it in and then Sonar charts turn on. You actually have to go in there, and it's an extra setting. It takes a second. I make it sound a lot harder than it really is, but it's actually an extra step. And I see so many people that have bought like a Platinum card or a Plus, and they just don't utilize that, and they're totally missing out on it. They should have just bought a Premium card because they're not even using Sonar charts. But anyways, that's kind of the gist of that. I think that's it. Yeah, that's pretty much it. It's a little bit. What time is it? 5:20. So yeah, we definitely spent some time on this. So right now, I'm here to answer any questions. I'll stay here as long as I need to. Ask me any questions. If there's anything specific, brand specific, now's the time to ask those questions. And I can't promise I'll get those answers to you right now, but I will sure look it up, look into it, and try my best to send you an email and reply to that. So for those that that are leaving now, thank you for attending. I really appreciate it. Hopefully this was helpful. Thanks, guys.